All right, so we continue from where we stopped. We were looking at transfer printing and what kind of paper should we use for transfer printing and what are the methods which are used for printing the paper. Screen is our own method, so the textiles, the flexography, gravure and lithographic methods are specifically designed for paper, and now the concept of 4-color printing is popular as far as the paper is concerned. All the colors can be obtained by the 4-color method, and what you only have is various kinds of dots, and the dots can be mixed in one proportion or the other to get a different color, and which is what is important for the paper. And of course, their principles are very different, and I am sure you would have appreciated the difference in the principles. Some people can ask this question as to, if you have the paper and you have done the transfer, how many times can you use the same paper? We said the cost of the paper is high. So, theoretically, obviously one time you can use it, and if you do a good job, which you should, a large amount of dye would get transferred, but it is never 100% transfer. Some of the dye may actually remain on the paper, and if you do it second time, this dye can get transferred, but obviously the depth of the print will be very different. So, if you have a customer who likes this, then you can sell it. For example, people in the upholstery have been making combinations of light printed and dark printed materials, which gives some kind of fashion trend. In case that becomes an issue, then you can obviously have the same print, same colors, but depth different, and one can have combination of alternate fabrics, drapes, which are light and dark. So, that is another way of looking at things. People do these things. More than 2, obviously there is no point, because you will only be having staining, there is no big transfer. So, the shade change may happen in case the rate of transfer of the colors that you have are not same. Let us say you have made a green, and this green has been made by 2 different dyes, and one of the dye has a higher sublimation rate than the other, then at the end you will find in the second case the dye is less. One type of dye is less, the other type of dye is more, and the shade has already changed. And so, when you print again, some shade change can also occur. So, that is the thing, but if you are looking for the best fabric, then it is better only once. If you are looking at fashion statements, you can have 2. So, we will now little bit talk about dyes and inks. So, dye is the dye that we talk about, the molecule. Ink is the solution which has the dye, all right. So, ink is like a paste which we are having in a printing, normal textile printing. In this case, we have a low viscosity ink, and they have the dyes which obviously are chosen based on certain criteria. One of the criteria obviously should be that it is sublimable, right. So, one can use different solvents for different methods, and maybe the viscosities may also be different, right. So, methods, the one which require quick drying, the one which do not require quick drying, have enough time, then you would be using methods and the solvents which are different. For example, if screen printing, normally people may use water based inks. So, obviously, it is a dispersed dye. So, it is water based, that means a water solution. It is aqueous based inks can be used for screen printing. For gravura, people may prefer volatile solvent. Toluene is present here, could have been benzene also. We do not use benzene anymore, you know why? Yeah, it is carcinogenic. So, benzene can only be used for research purposes, it cannot be used for any commercial product. So, toluene is as good, we just the next derivative. For flexo, people use ethanol water combinations, medium, and for litho, people may use drying oil which can dry easily, but it is all oil, as you know. You are dealing with hydrophilic, hydrophobic principles in this type of a printing methodology, and therefore, you would like to use an oil which dries, and obviously, it is only oil because it does not like water. That is the principle of the technology. So, dyes used for this are obviously sublimation, are obtained at the press cake stage before any other ingredients are added. So, normally if you are looking at a dispersed dye, you may get a paste or you may get a powder. Whether it is powder or a paste, invariably they would have added some dispersing agent in the dye powder itself. In this case, they are wanting to get a precipitated dye in a cake form and then make ink out of that. They do not want any additions to be made by the dye manufacturer, they want a pure dye, all right. If anything has to be added, then they know what to add rather than somebody else, because this is ink meant for paper printing. So, they are dispersed dyes, and we expect also that there should be low solubility. And this is also interesting that when, as we told, that the concentration of this particular thing may be very high, and when you have high concentrations, you can have precipitation, crystallization type of things. They should remain in the solution form for a long period. Ink may be containing some binding agent. This binding agent you can consider it like a binder which you use for a pigment printing, but obviously this dye is maybe in particulate form in some cases, and being held on to the paper by this film, right. So, it is expected that this film is not going to inhibit migration too much. You can never say that the migration will be not inhibited, but then you can give little more time. So, the film also should be such which does not really like the dye so much. So, affinity should not be very high, and the quantity of this binder should also not be so high, because if you have more quantity, then obviously some hindrance can occur. So, this is what the people will be preparing ink. So, you have a dye which obviously is the most critical part, and the other critical parts are the binder and the solvent that you use. You can appreciate that you will not be adding anything called an acid, an oxidizing agent or things like that, or alkali, because you are still using a paper. If you use acid on paper, you will have holes. So, nothing is to be done, it is just simple thing, just bound, And what are you saying is that the temperature when you are going to be actually kneading it, this will get evaporated and then it will just go from the paper to the fiber. So, some of the examples of the binders. So, different inks, different binders, what it means obviously is a water soluble, water insoluble, all those type of things will have to be seen. So, that kind of a compatibility people obviously work around. So, water based inks may have alkyl celluloses, the solvent based inks may have vinyl acetate based or acrylic based polymers, binders. The emulsion inks which they use, water toluene may have another chemical binder like hydroxymethyl cellulose. So, you have something which is compatible with most of them. You see, if you have incompatible, then there may be precipitation. You see, whenever you have incompatibilities, then you get precipitation. What you need is a nicely dispersed, free flowing ink. So, after this we can look at some of the characteristics of the dyes. We call them dyes because they are dyes, and you can appreciate that paper is only being used as a medium of transfer. So, this dye is not actually for printing a paper, it is only printing a paper for transfer. So, dye is exactly the dye that we are interested in the textile. And we are looking at the dry heat transfer. Which dyes is the question which may try to appreciate. Obviously, it has to be a dispersed dye. The transfer rate should be same for the mixture. This one has to work carefully by in consultation with the dye manufacturer. So, dye manufacturers give you charts which has all the experiments done on the dyes, and when you try to mix them up, you should know which dye to mix, because you will be using mixtures of dyes to get different shades. The temperature where reasonable amount of sublimation takes place may be different for different dyes. That also must be checked. So, one is transfer rate, the other is that the temperature at which the maximum rate is obtained should be also approximately same, because you invariably would not be varying the temperature during the transfer. You will use one particular temperature, could be 180 degrees or 200 degrees centigrade. Therefore, the dyes must be compatible in that manner. Fabric structure, theoretically one can say, well, why should there be any difference? Is the chemistry of the fiber which is an important thing, but not necessarily true. Suppose you use a non-woven polyester mat versus a tightly woven polyester fabric versus a knitted fabric, there are openings. So, there will be enough space, and so the dye can go through the spaces also on the other side, may get deposited, may not get deposited and transferred, right. So, the shades that you will obtain will be dependent on the fabric that you obtain. So, this is true, theoretically this is true with other printing also. If tomorrow you want to print carpet, so everything there is a pile, and you will not really get the same effect as you get in a tightly woven fabric, but that is nothing to do with the transfer printing process. But one thing is interesting, that you are pressing the paper, the fabric are being pressed and heated. So, some of the fabrics structure may collapse under the pressure. So, then you do not know where you are going to printing, on the side of the fiber or on the fiber which is, so there is a loop, for example. So, you wanted a loop normally supposed to be vertically thing. So, you want the colors and print on the surface. If all of them collapse because of the pressure, then the side will be printed which will not be seen. And so, one should know exactly how much pressure to put. If you put less pressure, obviously you can appreciate dye will go somewhere else also, and so that part remains. This difficulty is almost with every type of printing that you want to use. Even a roller printing has a pressure. So, if you use compressible material, then you can get different results. So, the dyes are known as the dispersed dyes have been categorized into various categories A, B, C, D, which is based on their sublimation fastness. So, if the sublimation fastness is poor, you say, well, it is A type of dye. If it is very high, then it is D. Also, they are sometimes classified as low energy, medium energy and high energy. Low energy means you require less temperature for sublimation, and medium energy is the same, and high energy means you require more energy for sublimation. So, advantage disadvantage will obviously be understood. In the normal dyeing processes and printing processes, the wash fastness may not be affected, but the sublimation fastness may be affected by this. So, they had decided to classify them based on what you want to use. In the requirement of a dyer or the printer otherwise, they would have loved to go for always D, right. But in the case of transfer, we really want transfer, we want sublimation to take place. So, there are opposing needs that we have. From the fastness, you like high energy dyes, but then they will not probably vaporize the way you want it, and so transfer may be, efficiency may be very poor. So, maybe somewhere somebody will say, well, somewhere the medium energy type of dyes are good for transfer printing, all right. So, some other things which obviously based on the experiment that people have done, if the molecular weight is very high, then it is also a high energy. If it is very low in the range of 200s, 250s, then again it is low. So, somewhere in the moderate range of 350, around 350 is not exactly a number, around this thing, people may like to have a molecule of this size. They could be azo or anthraquinone, which the dispersed dyes obviously are made. One important thing which as an oxochrome requirement is they should have minimum number of polar. So, polarity has to be less, non-polarity is better. Okay. So, minimum number of polar oxochromes, some are required because you have to give some shade, right, and no ionic group. Fortunately, dispersed dye do not have ionic group. The ionic groups, if they are there, these molecules do not sublime. So, for sublimation, what is important is the intermolecular bonding forces. So, when you say high energy, that means that the intermolecular bonding forces are stronger. If they are stronger, you require more energy to separate them. Vaporize means you have to separate each molecule, and therefore, you are interested that as less bonding that takes place will be good. So, that you give increase the temperature, kinetic energy will increase, any little less small bondings that they have will break, molecule will be free to move to the vapor and then go to the fiber surface and then go into the fabric. Ionic groups are obviously stronger than hydrogen bonds or van der Waals forces. If you have only van der Waals forces, it will be nice, they will evaporate faster. If you have a smaller molecular weight, it will sublime faster. So, this is how you people will be looking at some of the dyes in their features. Definitely no ionic. If you have dyes with bulky substituents, the steric hindrances would ensure that the close packing of these molecules does not take place. So, even if some dye and there are some groups which may like to make certain kind of bonds, but you have to come closer. You remember, bonding is like a contract. So, two molecules come together because by coming together they get to a lower energy state, otherwise they will not come together. If anything is a solid here, it is because the molecules like each other and therefore they want to come very close and stay there. So, if you have bulky substituent groups, the temperature required to facilitate vaporization could be low. The pressure, when you say pressure, what it means is that when you touch a paper and a fabric, we say we have touched and we are pressing, but it does not mean that there is no gap, and gap which we are talking about is, let us say, air gap. Two sheets of thing, there is an air gap. This is good enough, a gap for a molecule. Molecule is very small and therefore this gap is important. What is important? If the gap is more, obviously the molecule can go anywhere, and so the pressures will be also interesting. But bulky substituent groups are let us say it is a molecule which you would like to prefer. So, this is what I was talking about, free energy, which is known as the G, or change in the free energy. This delta G should be negative for anything to become stable, all right. And how can it become negative? If delta E is negative, that is the internal energy of the systems are negative, or the entropy is high. Entropy is a disordered structure in universe without your liking. Everyone wants to be free and move around everywhere. That freedom is basically the entropy. So, when the molecules come together and when they will not come together depends on the distance between the molecules. If the distance is large, then they may not come together. They may like to remain either liquid form or a vapor form, right, and because there is a kinetic energy available or whatever. So, they are far off. So, they can't make whatever you call a bond. For formation of a bond, the distance must be less than a certain value. If this is less than, let us say in this case this, then automatically these will reduce the distance and come closer, if this is the distance between the molecules or atoms, right. So, this is general principle which will happen. Same molecule would love to remain in random form, and this is thermodynamically acceptable structure condition, but they do come together. When they come together, that means a situation has been created where the distance between the two has been brought down to a level after which they will come automatically to this point. Why? Because all the masses attract each other, they attract each other, so they come closer. So, coming close is a good idea, but they can't go beyond a certain value, because if you come closer than that, then you have everywhere electrons. So, they start repelling if you come together. So, the energy goes up tremendously, and therefore, whichever type of a structure is possible, a hydroxyl group coming very near another amino group and they can make iron bonds, they can only make the iron bonds when they come to a certain distance. Similarly, to make a van der Waals forces, you have to come to another distance, right. So, or a covalent bond for that matter also another distance, you come so close that you are able to share your electrons from one to another, and so you will make different kinds of bonds. So, when we talk about high energy, that means there were some groups we could allow the molecules to come close together, and therefore, to separate them you will have to supply more energy, right. And that is how we have particles coming together, because they like, and when they come together means they are making some bond, maybe physical bond, but they are making bond. So, any situation that you create other than it being a dispersed dye, both are dispersed dyes here, and both have same molecular weight. So, molecular weight is one part, size of a molecule is one, the chemistry is also important, and here it is not even ionic in that sense, right. But what you see, one of the molecule, which is this one, can make intramolecular hydrogen bonds. They can make within the molecule itself. So, satisfied. If there is a possibility of making a bond within the molecule itself, they are satisfied. You do not have to go anywhere else. In the other case, when you have one hydroxyl group here, the other hydroxyl group on the other side, you see that within the molecule they cannot make any hydrogen bonds. They will make hydrogen bond with another molecule. That will be called the intermolecular hydrogen bonding. So, intermolecular hydrogen bonding will be possible in this, but not intra. But see the interesting part, at a given temperature, let us say 200 degrees centigrade here, in one case the vapor pressure is 1.18 millimeter of mercury, right. In the other case, it is 3.71 and 10 raised to minus 5. You see what the difference we are talking about? Which order are we talking about? A small little change can actually make such a big change in the vaporization sublimability, because the molecules can make intermolecular bonds. So, separating them will require more energy. In the other case, they are not making any such bonds because they are satisfied with each other. So, between the molecule there will be only van der Waals forces, right, but that is interesting. So, that was the polyester. So, you can obviously use polyester and disperse, as I said, as a good combination. So, can we do the transfer printing on nylon? Yes, we can do, right. So, in a conventional printing you like to use acid dyes, right. Can these be used for transfer printing? At the moment we are talking about sublimation transfer. Can they be used? They cannot be used because they are ionic. We said this is something which should not be there, there is no sublimation that will take place. One interesting thing is that dispersed dyes obviously dye the nylon, dispersed dyes obviously will print the nylon, and dispersed dye will also have the transfer also. One of the interesting thing which has been seen in nylon, which has not been seen in polyester, is the wash fastness of the dispersed dyed nylon fabrics will be low compared to the same dye on polyester. If the same dye has been dyed or printed onto polyester, the wash fastness is higher compared to the same dye in nylon. And one of the reasons why it is there is because the glass transition temperature of nylon tremendously goes down in moist conditions. That means at a very low temperature, which is room temperature, there is enough mobility of the molecules available. So, during washing also it can come out, right. So, if you do all the hard work with the dispersed dye and you find the wash fastness is not so good, we are not talking about sublimation fastness, we are talking about wash fastness, then it does not make much sense. But they can, acid dyes are good, they give good colors, whatever they give. Of course, you have metal complex, they will give you fastness also, but they cannot be used for thermal transfer. So, there is a class of dye which is been generated called disperse reactive. I mean, you did not, obviously you can understand, you did not want this type of a dye for polyester. What will you do with this, right? So, I mean, what will you do with the dispersed dye on polyester is anyway nice. So, you do not require a disperse reactive dyes for polyester. So, these dyes are the such which behave like dispersed dye at one stage, and after that you can get them reacted also. So, in that case wash fastness issue will be taken care of, and good for nylon actually. Theoretically you can always think, well, if you keep changing certain groups in a manner where they can react with any other group like hydroxyl group, then you can do on cellulose also. Nice thing would be that the same dye could be used for a polyester or a nylon cotton blend or something. Only thing is, how many people make nylon cotton blend, right? Or you can say polyester cotton blend where the reactive component can go to the polyester, reactive can go to the polyester, but it was the best for the nylon. If you use such dyes, then you can do thermal transfer printing as well. That goes by, it sublimes when it is just behaves like a dispersed dye, and then when it reaches there you can always create conditions which will then they can react. You can appreciate, like we already know, that the reactivity in neutral conditions of the amino groups is quite high, and so one can react in acidic medium, always. So, you can have a fixation in a different way. So, you may require another fixation, either it happens at the same time, but if it does not, then you can change conditions and then fix them up. For example, if this kind of a group is available, this group can react with the amino end groups of nylon, and if that happens after it is sublimed into or transferred, diffused, then you get the good fastness also. So, what is also important is that whenever there is a problem, you do not give up, but try to find another way, another solution to reach to some same goal, right. So, this is the way the organic chemists would be working, making a different kind of molecule which should do the same job. Acrylic fabrics, you know that they like cationic dyes which are also ionic, and therefore, they will not sublime, but they are very good from the tinctorial value, and fortunately acrylic fibers are much more hydrophobic compared to nylon, and therefore, whatever goes in does not come out very easily, all right. But you have to ensure that they go in first. So, dyeing or printing of acrylic is anyway more difficult in some sense, but once you do it, then they remain. So, some of the dyes which are in they, you see that triaryl methane based dyes in the acidic medium are ionic, right, but in alkaline medium they are not ionic and they can volatilize. Whether you will like printing ink to be alkaline is a separate story, because you have to store, right. Some effects can be there, but this is what. So, the normal dyes which are there, nice beautiful ones, there is an ion everywhere, it is not going to work. So, you have some ion here, some ion here, these are the resonant forms. If you do have ions, then you have a problem. Okay. So, there is an ion here on the nitrogen. So, this is a common cationic dyes which are good for the acrylic printing, but not for sublimation transfer printing. But if you have a dye like this, which is called the dye, you represent the dye as a dye which has got a hydroxyl group, and all other, this is a triphenyl methane type of a group, and because of this OH being there, it is possible not to have, that means not to have any ion there. If that is not there, then this can sublime. Another dispersed dye any sublime, that dispersed dye can also go, like it can go to the nylon, but normal basic dyes, cationic dyes have high tinctorial value, which everybody likes. So, if you want that, then you have to modify the dye in a manner that it is not ionic, but once it vaporizes, which is from the paper to the fabric it goes, there it can do this reaction, which you know this type of groups are available on acrylic fiber. From where do they come, these groups? Anybody else?
Sir, the end groups in acrylics we can't use cyanide group as for dyeing. Instead of that, sulfides and bisulfides group.
Right. So, the initiator.
Initiator.
The initiator which is used in the polymerization obviously does not go anywhere, it stays at the end, and because it stays at the end, which is ionic, so that ions are there. So, this dye can react with those at suitable conditions, and this type of a bonding may form, which is ionic bond, which is good enough. Once it is ion, then it is ion, anyway it goes out, you can do some washing later, right. So, this one of the ways in which you can have a relatively better looking dye on acrylic, right. Although normal dispersed dye which are going to polyester can also go there, but then they do not give that kind of a pictorial shade. Can cotton be printed by dye transfer? Dye transfer means you have dispersed dye, right. So, normally you will say it cannot be, right. So, you can say, well, normally no, unless you do something. Have you heard of interfacial polymerization? Interfacial polymerization is the polymerization which takes place at the interface, and if you have highly reactive compounds, monomers, in this case for example, sibacoyl chloride, which has got C10 and it is a chloride, not an acid. If it is an acid, sibacoyl chloride, if it is sebacic acid, right, instead of COCl, if you have COOH, this is not reactive, not that reactive. If you take a dichloride of this acid, which is cybercoyl chloride, it is very reactive. At room temperature, reaction can take place with, let us say, an amine, hexamethylene diamine. So, this is 6 hexamethylene diamine. So, you have a hexamethylene diamine, which is the same amine which is used for nylon 6,6 manufacture. But cybercoyl chloride is a different monomer, and this can react at the interface. The moment they touch each other, they react. So, you have to keep them separate. So, what do you do? One of them is soluble in water, other is soluble in organic solvent, and water and organic solvent do not mix. But if you create a situation that you are pouring something very slowly, immediately at the interface you will have polymerization. In fact, you can keep drawing the polymer from the interface continuously, and the continuously polymerization can take place. This is called interfacial polymerization at room temperature. You can use isocyanates. You remember, isocyanates are very, very reactive. Just touch the water and then they react. So, similarly, this is one of the interesting compounds. What kind of a nylon can form? It can form 610. So, this particular compound, you can make any other nylon also, change the monomer. So, you have one monomer which is the hexamethylene diamine, and the other is cybercoyl chloride, and they will make a polymer which is this 610. Have you heard of a process called Everland process? No? Everland process is the process which used this polymerization technique to onto the wool, so that the scales on the wool could be masked, because you have felting. That is one of the properties of the wool, and if you do not want felting to take place, you want to make shrink proof wool, as they say. So, one of the processes is that you coat the surface with a polymer, so that the scales get masked. So, this was a commercial process for wool. You could do tops or you could do fabric.
What kind of coating is this?
Nylon 610, the coating of nylon 610 using interfacial polymerization. So, what do you do? Pass the wool from one solution and then pass into the other. So, one of them is absorbed first, then you squeeze, and after squeezing take it to the other solution in a continuous manner, and suddenly find as it goes in and comes out, the polymerization is complete on the surface, right. If you do the same thing on a cotton fabric, you will get nylon 610. If you do isocyanates and hexamethylene diamine, you will get polyisocyanate polyurethane. Both of them are hydrophobic, and theoretically the dispersed dye can go and sit there after transfer, right.
Sir, can this affect during dyeing and printing coated wool?
Can they do what?
Affect during dyeing and printing of the wool coated with nylon 610 by Everland?
Of course it would. Of course it would. But then if you come to the wool finishing, they will say, well, do not, make a complete layer like sheath core where the fiber is absolutely inside the polymer. When then it will not be wool, it will be the polymer property. So, they apply very less, very less. Only thing they do in the case of wool is that you have the scales. So, you say well the polymer will be here and here there will be very less polymer. So, because of surface tension and other kind of things, the first the liquid has to go somewhere there. Do not absorb too much. Your aim is that something if goes here, then the friction in this direction and the friction in this direction would be more or less similar. So, that directional frictional effect which is responsible for the movement and the felting will be taken care of to some extent. There are other polymers also available. So, polymer coating is one of the ways in which you make shrink resistant wool. So, that is the possible solution. So, you can either do polyurethane with isocyanates or nylon with Cibicoil or any other acid chloride. You can get by the interfacial polymerization a layer of polymer which can absorb. It will never be as good as you say, like a polyester, but it will still do and certainly be very interesting prints. Of course, we will have to worry about what will happen to the abrasion resistance, what will happen to all those kind of things. They will definitely be something which one should bother. Other solutions could also be when you talk about cotton, esterification, etherification. They also make material hydrophobic. Like triacetate is fully hydrophobic, right. So, this is where we can stop, that these are the methods which can be used to do dry transfer printing on polyester definitely, which is the best substrate, and hopefully you can use for other substrates as well by some modification of a dye or some modification of the surface of the polymer. So, can be used for cotton and theoretically can be used for any other fabric if you can make a cotton. There we go. Thank you.